Hello, so I'm Laura Lewis. Welcome to this class on human activity and greenhouse gases. So this is part of GCSE chemistry. Okay, so let's look at the learning objectives. So a description of the activities that humans undertake that are contributing to the release of greenhouse gases. Number two, an analysis of the different effects of each greenhouse gas. And lastly, a discussion of how humans are elevating the greenhouse gases far above natural levels and data that confirms this. Okay, so let's start with a reminder, okay, from if you watch the video series, you've seen the other lesson about greenhouse gases. So let's just remind us that most of the atmosphere is actually nitrogen. There's 21% oxygen. Got a little argon from our light bulbs. 1%, and this is the one we're mainly talking about, the carbon dioxide at 0.04%. Okay, so it seems insignificant, but actually it's very plays a very big role in the climate. Okay, so you've got other trace gases like water vapor. So water vapor is also a greenhouse gas, but it depends on where you are on Earth as to it depends on where you are on Earth as to how much there is in the atmosphere. So a tropical region will have a lot more than a dry desert region. Okay, so again, other reminder about the natural greenhouse effect. So the natural greenhouse effect is that the greenhouse gases carbon dioxide, methane, and water, so H2O, actually help to keep the Earth warm. So this is one without the humans, so it's keeping the Earth at a temperature that's right for life. Okay, so without the greenhouse gases, Earth would be about -15 degrees, or mostly its surface, because it wouldn't be able to keep any heat in. Okay, like the greenhouse gases. But humans are putting more carbon dioxide, more more methane and other gases into the atmosphere that are causing the we'll talk about nitrous oxide a little bit later, actually causing more heat to be trapped, okay, within our atmosphere. So again, it's a bit of a reminder, okay, from another lesson, that the greenhouse gas is actually absorbing infrared radiation and re-radiate it back to the Earth. So that's from our other lesson, was about they trap infrared radiation from the sun and reflecting the Earth, radiate it back, okay, to the Earth. So the more greenhouse gases there are, the warmer the Earth becomes. That's generally how it works. Okay, so let's think about what humans might be doing. Okay, as an overview. So without any greenhouse gases, life wouldn't exist. But humans are putting a lot in. So the main one is carbon dioxide. They're releasing 82%. Also, carbon dioxide is not great as well because it spends a lot of time in the atmosphere. So once it's in the atmosphere, it's very hard to sort of take it out again. Okay, so it's called a long residency time in the atmosphere. So we also got methane. Okay, methane, 9%, nitrous oxides and fluorinated gases. So these are sort of smaller sort of players in it. Carbon dioxide is the main one. So how are we doing this in general? So electricity, okay, transportation. So this is burning fossil fuels mostly, these ones. Electricity, transportation, industry, we're burning fossil fuels. Agriculture, so we're going into a bit more detail in another slide about this. Okay, agriculture. Is because we're cutting down trees, deforestation, farmland, and cows also burp out methane as well. Commercials, so offices and things, we're using the electricity. Residential, because they're smaller. Okay, so let's get to a bit more detail. Okay, so what I advise you to do is sort of stop here and just obviously write down what you've learned so far. Okay, to make sure that you know what's going on, learning. Okay. And here are the answers, so let's just go through. So some of the radiation from the sun is reflected by the atmosphere back into space. Some radiation passes through the atmosphere, reflected off the surface. Greenhouse gas actually absorbs some of this radiation, increasing its thermal energy stored in the atmosphere. It's just a recap from last lesson. Greenhouse gases emit radiation back to the Earth, creating a warming effect. So this is revision, and then we've got extra bits. So the greenhouse gas and methane, carbon dioxide, water vapor. Humans are adding carbon dioxide to the atmosphere by burning fossil fuels for electricity and transport. Okay, so that's a summary. Now we're going to learn some more new things. So carbon dioxide, how is it really being put into the atmosphere? So we're putting carbon dioxide into the atmosphere by two main methods. So burning fossil fuels, so coal, oil and gas in vehicles or power stations releases carbon dioxide into the atmosphere. Okay, so fossil fuels are the remnants of dead organisms. So for coal, it's plants and trees that died about 300 million years ago that were buried, okay, and that they were buried in swamps in oxygen-free conditions, and lots of sediment like sand and mud was put on top of them until they turn into coal. Okay, so that's fine. Oil is plankton at the bottom of the ocean that's built up over time, so they sort of died and built up over time. Again, pressure and some heat cause it to compress and to turn into oil. And on top of the oil, you get gas. Now, this is an oil pumping plant. Okay, so when you first dig under the ground, it's called strike oil. It comes up under its own pressure. It's got a lot of gas in it. After it's to pump it up, so it pumps. This is a pump. Okay, and then the next one, deforestation. So rather than just putting carbon dioxide straight into the atmosphere, that people cut down trees, like the forests that people are cutting down here, to make way for farmland. Okay, so they want to farm the land, obviously to produce food. They cut down the trees, but if you cut down the trees, that reduces the amount of carbon dioxide taken out of the atmosphere. Okay, so it's actually, you're stopping it being taken out of the atmosphere. The deforestation is the main one. I mean, the crops they plant will take some out, but not as much as the trees. Okay, combustion. So there's a little bit more detail about why that's put. Well, it's still about carbon dioxide we're talking about. So natural gas. So this is important about the composition of it. So carbon, hydrogen, nitrogen. It's got some nitrogen, it's sulfur and oxygen. So it's not just got one thing in it. Okay, petroleum. So that's petrol. It's what we're known for. Oil, things like that. So it's got carbon, hydrogen, nitrogen, sulfur, oxygen. Yeah, some minerals in it, dissolved in it. Coal, similar, carbon, hydrogen, nitrogen, sulfur. Again, we're going to see it causes a problem later. And minerals. Okay, so this is the equation for combustion. So burning, so combustion is burning in oxygen. So you have propane, so you have a propane torch. So it's like that's natural gas. So propane plus oxygen goes to carbon dioxide and water. So this is a general equation for burning fossil fuels. Okay, so it always produces carbon dioxide and some water. Okay, but this is for detail for later. Okay, it's important. What the other things are in these fossil fuels? It's not clean to burn. Okay, so methane. Okay, this is asked a lot in exams, like methane. Okay, so increasing methane is a very potent, very strong greenhouse gas. We're not releasing as much of it as we are of carbon dioxide, but obviously it can contribute. So cows and other cattle, so they produce a lot of methane when they digest grass. I'm laughing because most of it actually, methane comes out of actually the front end of the cow when they burp, okay, because their stomachs, they've got 4 stomachs, you may know, they digest a lot of grass and that breaks down into carbon dioxide as a gas when they digest it, and they sort of burp it out. But if there's lots and lots of cows all over the world doing this, it can actually be quite a big contribution to the methane in the atmosphere. So also rice farming. Okay, so you may think plants are usually good, but depending on what type of farming, and obviously people are working around the world to change this a bit. I mean, still grow rice, but obviously not produce much carbon dioxide because they grow it in flooded fields. And I don't know, there's a rice paddy, you might have a paddy field, you might have heard it, in sort of Asian countries. They grow other places as well. I think America grows some of it. But sometimes on the practice they have flooded fields. That's just how the rice grows, and some of it sort of obviously is in the water, and it obviously naturally decomposes. So like bacteria break it down in the water. So these bacteria release methane when they digest it. So again, it's a bacteria digesting. It's not the rice itself that's producing it. It's decomposition by bacteria that produces the methane. Okay. So the other pollutant gases that are on some of the diagrams. So sulfur dioxide, I said about the sulfur being important quite a lot. So fossil fuels contain sulfur, they all do. So when it's burning oxygen, as a byproduct, sulfur dioxide, so SO2 is produced. Okay, so this can dissolve in water, like in the clouds, to produce sulfuric acid. So these aren't greenhouse gases, but there are the pollutant gases which you can be asked about. I've seen some exam questions where you are asked about this alongside the greenhouse gases. So these aren't greenhouse. I'm just putting one slide in. We're just saying that to note down there are other pollutant gases. So yeah, so sulfur dioxide, because it's produced at the same time as the carbon dioxide. Yeah, it dissolves in rain clouds in water, and it produces acid rain because it becomes sulfuric acid. And it rains down on the aquatic environments and the plants. It kills the trees. It can produce. It can cause problems for aquatic environments. So it becomes too acidic for the animals and plants to live in the water as well. Also, nitrous oxides, NO2, I think we saw earlier. So nitrous oxide can dissolve in water as well and produce nitric acid. And this obviously produces acid rain as well, and it can destroy plants and cause problems to aquatic environments, so usually like lakes and rivers and things like that. Okay, so let's have a look at some graphs. So the top graph on the left shows changes in temperature from the year 1860 until the year 2000. So it goes up and down, but the general trend is it's going up. Okay, so global average air temperature is going up. Okay, so that's going up over time. 1860s, Victorian times, when they started having steam engines and factories and things. Okay, the bottom graph also shows the carbon dioxide produced. It's about 1960. Okay, so in general, it goes up and down because of summer and winter. Okay, I always put that on because it's not always explained. Okay, is that it goes up and down because of summer and winter. So it's measured in the northern hemisphere. This measurement's taken from. So in northern hemisphere summer, there's lots more plants and they take carbon dioxide out of the atmosphere. So there's less carbon dioxide in the summer and there's more in the winter, but you don't need to worry too much about that. I'm just explaining why it's wiggling like that. So in this axis, it says carbon dioxide concentration in parts per million. So that's really just so if for every million molecules of air there is, as example, at this point, there's 380 molecules of carbon dioxide. So now it's actually gone up to about 420. They're still going up, okay, to this day. And so it's really the amount. So obviously the temperature is going up, and so is carbon dioxide. So we link these two things together. Okay, so let's have a stop and have a think about how you make notes of this and write this down. Okay, if you're presented with these graphs. Okay. So going back a bit further, you might think that's not far enough. So going back 400,000 years before today. Okay, so it says 1950 level and then current level. So we've updated it. Okay, so carbon dioxide level, again in parts per million. Like I said, now it's up to nearly 420 as of time of recording. Years for today, so it's going back in time, so 400,000 years, so nearly 500,000 years ago. So humans obviously weren't burning fossil fuels back then. Humans did exist, but we were we weren't burning fossil fuels. We didn't have the technology to do that. Okay, so you can see that it's gone up and down by natural phenomena. Okay, but but we've never gone above that line, and humans now pushing it above that line. So yeah, it's highest amounts in the last 500,000 years. Okay, so it's something to be concerned about there, that we're pushing it above its natural limit. Okay, so also some more data here. So 10 hottest years on record globally. Okay, so the 10 hottest years ever recorded have been in the last 20 years. So I think the figures for last year are still coming in. Okay, still being, so we've got 2019 as our most recent one. So it's not in year order, they year in the hottest temperature recorded average in that year. So 2016 was the hottest year on record. 2019 not far behind it. Okay, but yeah, it's getting more and more common to get a heat record. So in general, the Earth is heating up. Okay. Look at some questions then. Oh, yeah. So I'm just gonna take that off the screen so I can write on it. Okay. So it's from an exam. So particulates. Okay. So we're going to talk about those a little bit. The sulfur dioxide are pollutants produced when fuels burn. So particulates are soot, things like that. So actual particles. So nothing complicated. Okay. Particulates. So it can cause breathing problems in people. Okay. And also it can block out the light. So that's what we're going to talk about on this slide. So particulates and sulfur dioxide are pollutants produced when some fuels burn. So not greenhouse, but they're pollutants, and this will get mixed in with your question. Okay, and then yeah, they will try and trick you. So I've included this one. Okay, pollutant, but they're not greenhouse. So particulates are things like soot and soot and sort of particles. So what they'd actually, let me just put draw. Let me draw. Okay, so drawing tools. Is that going to work? Yeah. So particulates, they wouldn't cause acid rain. That's sulfur dioxide, isn't it? And nitrous oxides. Not called landfill. It would be nice to call a landfill. That's like rubbish. Sewage sludge, not really. It's actually global dimming. They block out the sun. Okay. And sulfur dioxide we talked about earlier. Acid rain. Okay, so I just wanted to make clear those. Next one. There's two. Exactly. This is what we were talking about earlier. Okay, so it's a bit of a recap. So we just put a text box in here. So this again from exams. So there's two human activities that increase levels of methane and carbon dioxide. So two for each. So methane, we know that. So cattle farming. So you have to name them. And rice farming. Well, easy enough, isn't it? So insert text box again. Carbon dioxide. So this one will be the obvious ones. Will be burning fossil fuels. It does highly link to geography, doesn't it? This. If you take geography at the same time, it's very helpful for you. I did that in other school, took geography. It does really help. Right, burning fossil fuels and deforestation. What people forget, isn't it? So it's easy as that. Okay. Okay. Oh, remember that this is the one I said was important about the elements because this is for an exam. And I sort of noted it down to talk about this video to students. Was about some things you might not think are going to be in it. Okay, so which elements do most fuels contain? So hydrogen, carbon, so there are hydrocarbons, and sulfur. Okay, so which gases are released into the atmosphere when a fuel is burned? Okay, so again, this is a little bit extra, isn't it? Asking if you think, oh, carbon dioxide, no, oh, there's other things, and this is what we were talking about. They'll mix in other things in the question. So fuels burned, so carbon dioxide, sulfur dioxide, nitrous oxide, and another one's actually water vapor. Do you remember the equation? People miss that one out, don't they? Okay, so four things, 4 marks. Okay, it's just sort of remembering, isn't it? Really, it's not really too difficult about this. I wouldn't say this is a difficult part of science. This one, it's mainly just remembering what you need to remember. Now I've presented it here for you. What they're going to ask you. Other than gases, what may be released from burning fuels? So we had particulates. Okay. And soot. So soot is actually carbon. Okay, so particulates could be anything. So it's about the minerals, didn't we? But it could be anything. So it can cause problems like that. Okay, so yeah, if I make a note all the things in this video. Okay, yeah, I tried to highlight things that they will ask you in exams a lot. So I looked through a lot of exams before I made this video and to find out what they're going to ask you, the GCSE chemistry. So thank you for listening. And I'm going to stop recording. Thank you and goodbye.